So hello everyone, how are you all? I welcome you in this particular video. In our previous video, we discussed about important properties of Laplace transform. Not only we discussed but also we derived also. In our first video, we derived the important properties of Laplace, basic properties of Laplace, how we can derive the sine property, cos property, exponential factor of Laplace and many more. In our second video, we discussed about the first shifting property. Like if any factor is multiplied by any exponential factor e raised to power 80, then what will be the final result? It shifts toward s minus a. That's why it is called first shifting property. Now in this particular video, we are going to learn the division property, multiplication property and many more. Particularly in this video, let's learn the division property, right? Whenever the factor f of t or function you can say is divided by the variable t, then how it depends on the final result. Okay, so let's write over there. So let's get started. So Laplace of f of t is equal to f bar of s, right? When you are getting the Laplace in the form of s, right? So in the form of s, that is function of s. That's why I am writing f bar of s. F bar of s nothing but f bar is a symbolic representation, right? It's nothing but a symbol, no notation, right? F bar of s, right? It's a function of s. So Laplace of f of t is long. So that's why for our convenience we are writing that f bar of s, right? For our convenience, simplicity. So Laplace of f of t divided by t, right? That means you are dividing with the variable t. You are dividing. So what will be the final result? Final result will be integral of s to infinity f bar of s ds. That means you are integrating the function f bar of s, which is the original Laplace of the factor f of t, and you are integrating the lower limit is s and the upper limit is infinity. Right? There are many more applications of this property. Now at first we are going to derive this property. How we can derive it? Let's see. So derivation or proof, what you say? So at first we are dealing with the right hand side. Okay, we are dealing with the right hand side. So what is RHS, the right hand side? That is integral s to infinity f bar of s ds. What is f bar of s? That is Laplace of f of t, right? What is f bar of s? That is Laplace of f of t. So in place of f bar of s, we can write the Laplacian form. That is the basic Laplacian form. That is integral of 0 to infinity e raised to power minus st f of t dt. Right? Laplace is combination of three factors, three things. Right? One is integral, another is exponential, another is factor. Right? So let's write over here. So integral s to infinity, integral 0 to infinity e raised to power minus st f of t dt. It is the f bar of s and whole thing is ds. So now it has been converted into double integral. In the type of double integral, multiple integral, we have many more application of this type of integration, right? So you know about this type of integration. If you don't know, then I will make separate video on multiple integrals. Okay, so integral s to infinity, right? So what is the format like ds and dt? So it could be separated, right? So integral s to infinity, that is right, ds or integral 0 to infinity e raised to power minus st f of t and dt. So it is function of s. So e raised to power st can be cooperated with this term. So e raised to power minus st here and this thing as it is. So this thing just like a showpiece, let it be right in this form. We are not dealing with that. We are dealing with this particular integral. So e raised to power minus st, integration will be e raised to power minus st with respect to ds. So minus t is also constant divided by minus t. So e raised to power minus st divided by minus s, and what is the limit? That is s to infinity, and put as it is like a showpiece f of t dt. So at first apply upper limit over here, then apply lower limit over here, upper limit minus lower limit, that will be the thing, right? So integral of e raised to power 80 dt, what is the thing? E raised to power 80 divided by a. Whenever you are differentiating, you multiply the factor a, and whenever you are integrating, integration is the reverse process of differentiation, right? The reverse operator of derivative. So you are dividing. So whatever will be multiplying and we are dividing in this integration. Okay, right? So minus s as it is. So sorry, minus s is not there, minus t, because here minus t is constant, because with respect to ds we are integrating, that's why s is variable, but here t is not variable, t is treating like a constant. Okay, right? So e raised to power minus infinity, so put the upper limit. So e raised to power minus infinity is basically 1 by e raised to power infinity. 1 by e raised to power infinity, what? 1 by infinity, that tends to 0. So that upper limit we are putting over here, that is 0. So 0 minus, now put whatever t, so now put is this, so e raised to power minus s into t by minus t, that will be, what is that? That is minus s. So minus minus becomes plus, so we can write it as it is. So integral 0 to infinity, sorry, that thing will be t, sorry, that thing will be like t. Okay, so integral f of t dt. So let's remove over here. So we can put it in the inside box, so that will be integral 0 to infinity. If we put inside that integral, then e raised to power minus st into f of t by t dt, right? Are you getting? So now this factor is like f of t by t, that is Laplace of f of t by t, that is LHS. So LHS equal to RHS, so that thing is proved. So it is the basic derivation. So what is the trick behind it? You simply hide this multiple integral wherever there is e raised to power minus st ds. Now separately integrate with respect to s to infinity. So e raised to power minus st, here minus t is a constant, so minus, so put at, so e raised to power 80, so e raised to power 80 by a, e raised to power 80 by a whenever you are integrating with respect to dt. So a is constant over here. Now you are integrating with respect to s, that means rest of the things are constant, minus t, so minus t over here. Now s to infinity, now wherever there is s, put s, right? S is variable, so wherever there is s, so put s. T is a constant, right? T, no need to worry about it, t is constant over it. So the final result is like that. So Laplace of f of t by t. So now let's understand few example problems regarding this property. Okay, right? So let's erase this because space is limited over here, right? So I hope you are getting. So Laplace of, let's write one important example, Laplace of sin t by t. So how we can deal with that? Laplace of sin t by t, Laplace of sin t, that is basically 1 upon a square plus 1. So Laplace of sin t by t, it is f bar of s. Now integral of s to infinity f bar of s ds. So integral s to infinity ds by this whole thing s square plus 1, that will be simply tan inverse of s to infinity. So tan inverse of infinity minus tan inverse of s. Tan inverse of infinity is basically pi by 2, 90 degree, because tan of 90 degree tends to infinity, undefined basically. So here pi by 2. So pi by 2 minus tan inverse of s, that is basically cot inverse of s, because we know tan inverse of x plus cot inverse of x results pi by 2. Okay, so the thing is like that. So let's get one another example, that is Laplace of cos t by t. Laplace of cos t by t. So Laplace of cos t, we know how we will identify that by t is there. So division is there. That's why we are dealing with division property. You can solve it directly without any integration. If you don't know this property, now you will getting bothered with the integration. Now we will be having the Eigen rule, the successive integration rule. Now very much longer method. If you don't know this property, so Laplace's property are very important to solve any kind of problem, right? So Laplace of cos t is s by s square plus 1, right? Laplace of cos of at was s by s square plus s square. We derived also using the complex number e raised to power iota theta equals cos theta plus iota sin theta. You can check out that particular video, that is the previous, like first video of regarding Laplace transform. Okay, Laplace of cos of t by t would be integral s to infinity the whole factor, that is the function f by of s ds. So half if you multiply, so So it is basically the denominator is the function and numerator there is derivative of the numerator. It is derivative the a square plus 1. What is the if you differentiate so 2s is about so half of log mod a square plus 1. If you put mod or you do not put, that doesn't matter in particularly in this case, because a square is already positive, so a square plus 1 is already positive. A square plus 1 is greater than 1 for any kind of value of a real value. So that's why you put mod, because it is already positive, right? So you put mod or do not put, that doesn't make any sense or doesn't matter. So s of s to infinity. So that will be the result. So if you just put the thing over here, so Laplace of cos of t minus cos of 2t by t, what will be the value? That is Laplace of separate, Laplace of cos t by t minus Laplace of cos of 2t by t. Laplace of cos t by 2 is half of log of a square plus 1, and Laplace of cos of 2t, if there is 2t, so s by a square plus 4. Okay, the rest things are constant, so s by a square by 4 over here. So s by a square plus a square, so 4, so half log of a square plus 4, and the thing is s to infinity. So half log a minus log b is log a by b, you know. So a square plus 1 by a square plus 4, s to infinity. If you put infinity over here, that is log of 1. That is log of 1 is 0. So 0 minus half of log of a square plus 4 by a square plus 1. So negative will be the power, because log of a raised to power b is b log a. The power comes down, jumps up. So minus, if you put this minus over here, negative. So reciprocal of this, inverse of this, so half of log of a square plus 1 by a square plus 4. It will be the final answer. I hope you are getting this kind of topics. So if you have any doubt regarding any particular place of this, any particular doubt, so regarding this Laplace transform, regarding any property, regarding any derivation, now put comment in the comment section. I will give the answer separately. I will try to do my best. Now if are you getting all the formulas or derivations, let me know in the comment sections. In our next video we will learn the multiplication property, periodic function of Laplace, inverse Laplace, convolution theorem, and many more. So subscribe and like and share if you like this video properly. Okay, so thank you for watching this video. I hope you are getting. Thank you.